Hi guys, welcome back to my channel. We're still dealing with fluid mechanics, properties of fluid mechanics, fluid N5. This is still fluid mechanics N5. We're still under viscosity. This example, this is an example. We'll be dealing with this an example that I've taken from your textbook, right? Then the next coming session I'll be dealing with the problems of this viscosity, but I will be taking from, I will create them, others I will take from previous question paper. We'll be dealing with them. So let us focus on this example. I want to explain using the same example that you are given on your textbook. So you can quickly go, it's page 6, right? It's page 6 on your textbook if you are using this textbook. But this textbook, you see, this textbook is no longer, the syllabus is changed, but what I'm showing you is necessary. Not everything is changed. This is not changed. The topic that I'm dealing with are not changed. Using this textbook, we'll look this example. You see, we'll be dealing with this example. Now I want to explain it for you guys so that you understand when you are dealing with questions, how will I take them. I will take from the previous question paper, some I will create them. I will just create the questions, do not worry. Then let us focus here. We're given this example is read as follows. It says a plunger with a length of, we are given a length and a diameter of the length of 110 watt, must be, it's millimeter. Yeah, it's 110 millimeters. 110 millimeters and a diameter of 80, moves with velocity. You are given a velocity inside a cylinder. Remember, a plunge, this is like a plunge. You can say this is the same like as a piston. You can say piston, plunge is a piston with a length. This is the length of it with a diameter. This is a small d of the piston. You can say is the piston. It's a plunge. You can say it's a small d. This is the d of the piston. Moves with the velocity, and then velocity, remember, is represented by x bar there, inside of the cylinder with a diameter of 80,1 millimeter. This is big D. Big D is the diameter of the cylinder, right? This diameter of the cylinder, this is a big diameter of the cylinder. The absolute coefficient of viscosity of the oil in the cylinder is viscosity. Coefficient of viscosity we are given is 0,15 per pounds pass, right? We are given it. This is the viscosity. They've stated this is new actually. This is coefficient of viscosity. Now let us try to deplete what we are given. If we can deplete this, remember I said on the previous video, I've explained, they've given us, you read the statement, they've give you what? A diameter with a length. Yeah, one. They say the plunger with the length. Yeah, understand. And then this length must be a length of the piston, not a conducting rod. It's like this. We have a piston. This structure, we have a piston like this. You can say I have a piston. I have a piston here. Then here I have this is a connecting rod. Here is a piston. This is the piston. right? It's in the this diameter of it, small d, it's what? Its diameter is 8. It's 18 millimeter, right? It's 8 millimeter, right? Then the length and the plunger with the length. This is a length. This is length. When talking about, we don't include the piston. We don't include the collection rod. We are focusing on the piston or on the piston. This is the length of the piston. It's not of the cylinder. No, it's the length of the piston. We use the length of the piston. This is the length of the piston. Let me just crack it down. This must be the length of the piston. You understand? Not of the length of the piston is 1 millimeter. The length of the piston, this is L, right? Now we are done. It says it moves with velocity. That means it's moving. Then with the velocity, I can say this piston is moving that direction. I can say x velocity is represented by x dot. It's moving with has 3 meters per second. I can say it's moving that direction, the piston, right? Now this piston moves with velocity inside the cylinder. Now we have what? A cylinder. We have a cylinder, right? It's moving inside. We have what? A cylinder. Now the cylinder is how much? You check, you see, it's big. It's supposed to be what? The clearance is not exactly. You see, it is not the same. Then here it's a cylinder. It's moving inside the cylinder. You can see we have cylinder here. It's moving inside the cylinder, right? It's moving there. Here, this space is supposed to be what? Clearance. This space, it is what? The clearance. The diameter here, it's of the cylinder. Big D, it's a D like this. Big capital letter D, big capital letter D, which is this diameter. We're given as 8,1 millimeter. It's 80,1 millimeter, right? Now, this is the length. It's not, you see, it's the length of the piston, not of the, we don't deal with the length of the cylinder, no, for now. We are not focusing on that. Now, we have all of our stuffs here. Now, the question says, determine the force to move the plunger. The force, which force is what? They want F. The force. Remember, the piston is moving that direction. That means there was a force that is applied. We want that force. What is the force that caused the piston to move? The force that was applied. And then we know under this topic, I've showed you how to calculate the force. Remember, right? I said the force is given by this formula. F is equal to what? Area multiplied by coefficient of viscosity multiplied by velocity divided by what? By clearance. Right. Now I said again, the area, we focus on the piston or plunger, we focus on the piston, will be is given by pi d small d. I'm using this d small d multiplied by L. I said this d is not of the small d, is not the d of the cylinder, it's the diameter. It's not the diameter of the cylinder, it's the diameter of the piston, small d. Of the piston must be of the piston or plunger, right? This d. Also, this is the length of what? Of the piston. not of the cylinder, of the piston or of the flange. Do not make mistake. Do not make mistake and use of the flange. You understand? Area. So if we substitute area is equal to pi multiplied by diameter. Small diameter is this, is 80 millimeter. Then you punch your calculator. Will be when you divide by 1000 is 80 millimeter, right? 80 divided by 1000, you get 0.08. You multiply by the length of the piston, not of the cylinder. Of the piston is this one, is 110. You divide by 1000 to convert to meters will be 0.11, right? Then punch the calculator. Tell me what do you get there from the area. If you punch it, you're supposed to get 0.02765 meters squared, right? This is what it's in. It's area. We have found the area. We are done with this one. What about this? We are given this. We are given what we are looking. What short? What is left is clearance. We don't know the clearance. We can able to calculate it. This CR clearance. Remember, I said the clearance is the D, big D, diameter of what now? I said you use only this diameter will be used only when you calculate the clearance. The diameter of the cylinder. The diameter of the cylinder. It is used only for calculating a clearance. Only. Nothing else. Clearance only will be used only when you are calculating a clearance. Only. Nothing else. Diameter of the what? Of the cylinder. Diameter of the cylinder minus small d of the flange or piston. You can say piston or flange, right? Divided by 2. Always. It's when we are applying this diameter. You understand? Do not make a mistake. Clearance. What is the diameter? That is 80,1. You divide that 80,1 millimeters. 80,1 millimeters. Let's convert to meters. You divide by 1000. Then will give you 0.0801. You subtract the diameter of the piston or plunger. This one 80. Subtract that one will be 0.08. You divide by what? By 2. Then you punch your calculator. Your CR is what? Your clearance. You'll get that your clearance will be 0, with 4 zeros, 1, 2, 3, 4, and 5. Measured in mid. It's measured in mid. Right. It's your clearance. Then, since you're done with clearance, now we can use this formula because we have clearance, we have velocity, we have this, we have the area. Now the force, question A. Now the force, remember this is A, we're answering A. The force, we know the force is area multiply by coefficient of viscosity multiply by velocity divided by clearance. What is area? We have substitute that area, which is 0.202765 multiply coefficient of viscosity here. Mu is this one here. We have it. They've given us the oil is 0.175, right? They've given us there multiply by velocity. They've given us the velocity here, which is 3 divided by clearance, the one you've calculated, it's 5. Then you punch your calculator. You will find that the force, it is 290, 283 Newton. Right, we are done. We are done with what? With the force. You have found the force. This is the force. We are done answering this question. Question 1, we are done with it. The force to move the plunge is the force that is required there. Then the power, P, power. Remember, power is calculated by, will be a force multiplied by velocity. Right, force multiplied by velocity. We have the force, we have the velocity. The force is 290,283 multiplied by 3. Multiply this by 3, right? Multiply this by 3. Then you'll get that the power that you'll get, the power you'll get, let me write here, the power will be would be 870,85 watt. And this is the power. Using this formula, you substitute your force, you multiply by the velocity. This is what you will get. Here, this is what is continuing here. This is what you're supposed to get. Then that is the power. That is the power, right? So yeah, just apply. Remember, we're still under what? This is not a shaft. It's piston. This is the piston and cylinder. The piston and cylinder. Remember, this is the piston and cylinder. We are still is not. We are not dealing with the shaft. We are still dealing with the piston. It's moving. It's a linear motion. It's a linear motion. Okay, thank you guys. Do not forget to subscribe to my channel and stay notified and stay tuned when I post the new videos. Share it to your fellow classmates. Sharp.